Good afternoon. Uh, good. So yesterday, yesterday we did derivatives in it. The derivatives. Yeah. If we are given maybe what the function, which is f of x. Yeah. We derive by using what the power rule. Yeah. The derivative is represented by what? By f prime of x. Yeah. So ka power rule, re itse re na le a x to the power n. Akere ha re derive ntho re tsang re tlosa n ena re tlisa fatshe akere ra tlo ba n a x n minus 1, just like that. This will be what? This will be the derivative. So mabane ntse re derive mara today I want you to know, okay, what does the derivative mean? What does it mean going for a function? So this thing, the derivative, it actually means this is the formula of the gradient. This is the formula that we can use to find the gradient at any point on this function. This is the formula that we can use to find what? The gradient at any point on this function. For example, straight line sa rona ha re sebedisa straight line re thola ka y is equals to mx plus c. Akere ka re na le y e re ke se ka sebedisa y ke sebedise f of x, which is f of x is equals to mx plus c. F of, here it's example here, f of x is equals to 2x minus 4. Akere this thing, it represents what does it represent? This thing, it represents what? The gradient. Where 1 and 2, the gradient. And we know that the derivative of a function, when we derive this function here, it gives us what? It gives us the gradient. Okay, let us derive this thing and read in f prime x. I know that. So how we derive and to f prime of x. Ele kana le eng? Hona le bokae mo? Exponent mo 1 akere 1 ya theo 1 e tlo multiply le kae le 2 bere x 1 minus 1 akere ke yang n minus 1 akere re itse the derivative of a constant ke bokae di rules tsene re di tsama 1 is 0 by 1 and 2. So this is a constant, so it becomes what? 0 akere. So f prime of x e tlo kana le bokae le 1 multiply by 2 multiply by x to the power 1 minus 1 ke bokae ke 0 here. F prime of x e tlo kana le bokae 1 multiply by 2 multiply by 1 1 multiply by 2 multiply by 1 ke bokae ke 2 by 1. So it means what? F prime of x, which is what? Which is the derivative. I get the derivative. What does it mean? What does it give us? It gives us what? The gradient. In this case, the gradient is a constant. Answer ke 2. We know that gradient of straight line is what? A constant. I get because straight line so maybe this is going to be what? This is just going to be our maybe minus 4. Then it will be positive. We know the gradient is a constant. So gradient is 2. So now, what if now it is not a straight line? Ke bo parabola so. Ne? Ke bo parabola. So re tlo etsa jwang ha ile jwalo? Ha ile jwalo, ha re reng re na le f of x, which is equals to ile kana le x squared. So ha re draw parabola ya rona, in that case e tla be le jwang? E tla be le so. This will be the graph that is given by what? By f of x is equals to x squared. This one. So if we find the derivative, yeah, f of x, that derivative, it will refer the equation, yeah, gradient. But because this one is a curve, I want to get a parabola, curve, meaning gradient that thing is wrong, high constant. In a gradient that thing is wrong, a constant. Mona gradient that thing is wrong, a constant. So we are not expecting to find f prime x is equal to the 2 ma, my 1 and 2. So how is the derivative of that? Now, let's look at f prime of x. Now, it will look at the 2 here, 2 x, you 2 minus 1 using the power rule here. Now, it will into it will 2x, 2 minus 1 give 1. Now, f prime of x is in the 2x. Key into is the derivative. What does it represent? It represents what? The gradient. Here, the gradient on this curve, on this parabola. So what does it mean now? It means if we have this, we can find the gradient at any point on this graph. At any point on this graph. Right? So mole, maybe mona give kai 1. Here, we can find the gradient mona give kai. And then we can still find the gradient okay. Man, okay. Who 2 more x lim kai. Ili 2 nga thola gradient ya teng ke kae. Di gradient tsena ha di no tshwana ya 1 le 2. Why di sa tshwana? Because ena ke curve ya curve akere. Ena na ke eng? Ena na ke straight line, that's why it's constant. But gradient ya ka mo, di gradient ya ka man ha di no tshwana. Ma ke tlo di thola jwang? Ke tlo di thola so. Le tlo f prime at 1. A ke batla gradient e kae? Where x is equals to 1. It will be 2 into 1. Gradient ya ka ke bokae mo? Ke 2. Ho kae? Mo x le 1 graphong ya ka. Gradient ke bokae? Ke 1. Ke 2. Ya bona? Be ke batla eng hape? F prime of 2. F prime of 2 e bolela eng? F prime of 2. Equation ena ke eng? Ke eng? Ke gradient. Meaning ke batla eng? Gradient mo x le bokae? Mo x le 2. Man ke batla gradient ya man. Gradient ya mo e tlo ba eng? 2 into 2. E le kana bokae? 2 times 2 ke bokae? Ke 4. Ba bona? So gradient ka mantsama e ntse tlo nyoloha ha ntse ba bona ha ntse ke re 3 e tlo ba 2 times 3 e ba 6. Meaning ha ntse ya kwa ntho rona ntse ba jwang? E ntse e ba steep e ntse e ba steep. I understand ntho ke buang. So it means the derivative ha re derive a function re thola equation e re thollang eng? E re thollang gradient at any point on the graph. So sometimes ba ka nna ba ho wena find the equation of the tangent. Find the equation of the tangent that is passing at x equals to 1. It is a tangent to f. What is a tangent? A tangent is a straight line that only touches the curve at one point. Right? So our tangent in this case, it's a straight line. We know that the tangent is what? Is a straight line. Again? But it touches a curve only at one point. Information in that. The tangent is passing where? At x equals to 1. But we know that equation of straight line is y is equals to mx plus c. Right? So tlamehile re thole eng pele? Tlamehile re thole gradient. Ha re qeta ho thola gradient, re thole eng? The point on graph. Right? So re thola jwang? O tlo batla gradient e kae? O derive ntho akere re thola gradient ya rona at x equals to 1. Gradient ya rona re thotse le bokae? E le 2. So it means gradient ya line ena e tlo ba bokae? E tlo ba 2 because e feta kae? E feta hona mo 1. Right? Se re tseba eng? Se re tseba gradient. But now they said find the equation. We're looking for what? for the equation of this what? Of this tangent. Right? So we need to find what? A point on graph. So the corresponding y value mona ke kae. Right? So the corresponding y value tla ba kae? Ha ile 1 mo. Ha mo ile 1, mane tlo ba kae? 1 squared. Ha o re tletsa mo, e tlo ba eng? 1 squared. 1 squared ke kae? Ke 1. So mona na ka mantswe a mang di-coordinates tsa rona ke 1:1. So if we are looking for what? The equation of the tangent at x equals to 1, tangent at x equals to 1. Again, ka mantswe a mang se re tseba gradient ya eng? F prime at 1 ke kae? Ke 2. Point ya rona ke eng? Point ya rona ke 1:1. 1:1, like that. Therefore, it becomes very easy. We say y is equals to mx plus c. Y ke kae? Ke 1. Here. And then gradient ke kae? Ke 2. X ke kae? Ke 1. C ke kae? Re batla le c. So you say 1 equals to 2 plus c. Re transpose ntho ena here. Eba 1 minus 2 di kana kae? Di c. C di kana kae? The negative mang? C to kana negative 1. Here. So meaning our y y is equals to 2x minus 1. Ke equation ya eng? Ke equation ya tangent. Right? Mara itseng find the equation of a tangent at x equals to 1. Right? Mara ba re file curve ya. So re qala re etsang rona tlamehile o derive akere o thole the equation ya eng? Ya gradient. And then o lo substitute kae mo equation ya gradient? O substitute 1, meaning o thola gradient ho kae? 1. Ke gradient ho 1. Re batla eng mara? Tlamehile re be na le a point. Point ke eng? Ke x le eng? Le y. So re kenya 1 kae? Man. Re thola the corresponding y value. Re khutlela kae? Straight line sa rona. Re kenya y mona na x man le gradient. We find c. And then after finding c, we substitute everything back except for y and x. Yenana. Re thotse. Le bona e tswa jwang? E re ke le fe few question kgona ho practice ka yona. Danko.